Good morning, good afternoon, Miss Lavnika, Miss Mate will be talking about transformation of quadratics today. First transformation is y equals ax squared. That seems a little bit too general to me, so let's look at some examples. What do I mean with this y equals ax squared? My first example that I reveal here is y equals 2x squared. How much is a in this case? It's 2. Okay, let's see one more. How much is a in this case?
1/2.
Okay, and one more.
-1.
Oh, okay. I see that. And the last one is a equals
-3.
negatives. Good. So now what our objective is to graph this function and see the connection between the original one, y equals x squared, and the new function 2x squared or whatever we have there. Okay, so we are now in Geometry Sketchpad and we will be looking at an investigation.
So what we have a simple parabola, vertex at 0, 0, and a value is 1.
Yes, I can see there is y equals 1x squared. Good.
Correct. So if I would make a greater than 1, what will happen to my parabola? So let's see, observe what is happening to my parabola, and also see what is happening to my equation.
So there you go. I see what happens with the equation becomes 1, 2, 3x squared. So the x squared is multiplied by different numbers. And I also noticed that when I look at the parabola, let's look again at the parabola, what happens is the y coordinates are multiplied, are increased. What do we call that?
That's right. So we say that the parabola was vertically stretched, and the y values of every single point on the parabola was multiplied by coefficient a.
Let's go back to a equals 1. I have my original parabola. What happens now if I multiply x squared by a value of coefficient between still positive but less than 1? Can you show me what happens?
So if I make my a value greater than 0 but less than 1, my parabola is getting wider, as you can see.
Right.
And what it means, we call it vertical compression. And the y values are multiplied by coefficient, in this case 0.36.
Okay, now what happens if I'm going to multiply my x squared by negative numbers? For example, let's multiply first by -1, so my parabola is negative x squared. What do I notice? I notice that all the y coordinates were multiplied by -1, so I get a reflection in the x-axis.
That's right. So let's see what happens if my a value is greater than -1 and less than -1.
Right,
so it's a -1.91 in this case. And again, the graph has been vertically stretched, and if my a value is between 0 and -1, let's say -0.32, my parabola is vertically compressed.
Okay, so now I looked at what happens with the graph. What I need, let's look together at a specific example. We have my original function, my parent function, y equals x squared, and y equals 2x squared. And I am going to look at some specific values on these two graphs. Can you please help me, Ms. Lavnika, with my favorite all-time
5 points.
5 points, yes.
-2 and 4.
-2 and 4.
-1 and 1.
Yes.
0, 0. 1 and 1. And 2 and 4.
Good, I got that. So I am multiplying my y coordinates by 2. Here I multiply by 2. So what happens is all my y coordinates from my original function are multiplied by 2. Okay,
so that will be 8.
Okay, I got that.
-1 and 2.
Yes.
0, 0.
Okay.
Doesn't change.
Yes.
1 and 2.
1 and 1 times 2, yes.
And 2 and 8.
4 times 2, that's an 8. So let's look now at the graph. Let's see what happens. My blue function, it's okay, we'll get back here. So my blue function is my original one, y equals x squared. I do not believe, I want to make sure that my 5 points are there, 1 and 1, 2 and 4, negative 1 and 2, 2 and 4. Now I believe we are talking about y equals x squared. And let's see point by point what happens after I multiply by 2. So this point over here becomes
2 and 8.
So
negative 2 and 8.
Negative 2 and 8 multiplication by 2. It's a vertical stretch. 1 and negative 1 and
2.
There you go.
0, 0 stays the same.
Okay.
1 and 2 is the next point, and 2 and 8 is my next point.
8 is my next point. So there you go. These are the 5 points, and all the y coordinates were multiplied by 2. I have here a vertical stretch. The next example here is y equals x squared and y equals negative 1 over 2 x squared. Help me quickly with the same points.
So it's a negative 2 and 4, negative 1 and 1, 0, 0, 1 and 1, and 2 and 4.
2 and 4. And now what else do I need? Let's see what happens here. All my x coordinates will stay the same. Nothing happens to them. However, tell me please what happens with the
Y coordinates are going to be multiplied by negative 1 over 2, and that will be negative 2.
Right.
Negative 0.5 or negative 1 over 2,
Okay.
0.
0.
Again, negative 1 over 2.
Right.
And again, negative 2.
Okay, so let's look at the graph now. Okay, so initially y equals x squared is blue. I don't believe right away. I can look at the points. Yes, here they are. 2 and 4. And now let's see the corresponding. By multiplying by a negative half. 4 becomes negative 2. Yes, I can see it. Negative 0.5. 0 stays the same. Half. And the last one is
Negative 2.
Negative 2. Okay, so let's sum up. What happens with y? What kind of transformation is y equals ax squared? Well, it depends on the values of a. If a is greater than 1, what kind of transformation do I have here?
We are talking about vertical stretch.
Vertical stretch by a factor of
A.
Factor of a. Good. As it was the case with 2x squared. If a is still positive, however, in between 0 and 1, I still have a vertical transformation, but it's not a stretch, it is a
compression.
It's a compression by a factor of how much?
1 over A.
Factor of, actually it's going to be a because a is 1 over 2.
Oh, okay.
Right? So then if a is negative 1, let's take that case into account. What happens with a is equal?
The parabola is reflected by x-axis.
So I have a reflection in x-axis. In x-axis. Good. So that's about it. We've seen all 3 examples.